Welcome to Master Mathematics Minutes. Today's topic is about perfect square factorization, and we'll cover a couple examples on how to apply the perfect square factorization, and we will conclude the topic with a summary. And finally, be kind and subscribe for more videos. So, what is perfect square factorization? Consider the perfect square a plus b squared. We can write that as a plus b multiplied by a plus b. And by expanding these brackets with a multiplied by a as the first term, a multiplied by b as the second term, a multiplied by b as the third term, and b multiplied by b as the fourth term. That simplifies to a squared plus 2ab plus b squared. Therefore, the perfect square factorization is as follows, with a square plus 2ab plus b square, being this term here, as equals to a plus b multiplied by a plus b, being this term here, and that is equals to a plus b squared, being this term here, a plus b squared. So all we've done is rewritten this line backwards. So when you're given this a squared plus 2ab plus b squared, you could factorize it to be a plus b multiplied by a plus b, or a plus b squared. And that is basically what we call the perfect square factorization. Let's consider a different perfect square with a minus b squared. And we can rewrite this as a minus b multiplied by a minus b. So with a multiplied by a as the first term, minus ab as the second term, minus ab as the third term, and b multiplied by b as the fourth term. And that simplifies to a squared minus 2ab plus b squared. Therefore, the perfect square factorization is as follows, with a squared minus 2ab plus b squared, which is that term here, that's equals to a minus b multiplied by a minus b, being this term here. And that is equals to a minus b squared, which is this term. So all we've done is rewritten this line backwards. So when you're given a squared minus 2ab plus b squared, you can factorize this to be a minus b multiplied by a minus b, or a minus b squared. In the first example, we're asked to factorize the expression x squared plus 2xy plus y squared. So, notice that this is in the form of a squared plus 2ab plus b squared, with the a being equals to x and b being equals to y. So we saw earlier that we can factorize this to be a plus b multiplied by a plus b, or in other words, x plus y multiplied by x plus y. In the second example, we're asked to factorize the expression s squared minus 10s plus 25. We can rewrite this expression. So s squared is unchanged as s squared, and 25 is now 5 squared. So for the middle term, we'll need to write it in the form of minus 2ab. So we have s being equals to a, we'll copy s, and 5 being equals to b, and we'll copy b. So these two terms are ab, and we'll put a minus 2. So if we were to multiply this out, with minus 2 multiplied by 5 is minus 10, multiplied by s is minus 10s, which matches this term. So this is now in the format of a squared minus 2ab plus b squared, with a being equals to s and b being equals to 5. And we saw that this can be factorized to be a minus b multiplied by a minus b, or in other words, s minus 5 multiplied by s minus 5. In the third example, we're asked to factorize the expression p squared q squared plus 20pq plus 100. So we can rewrite this expression. So p squared q squared is now pq, the entire thing, squared. and 100 is now 10 squared. So this is now in the form of a squared, with a being equals to pq, and b squared, with b being equals to 10. And for the middle term, with 2ab, which is 2 multiplied by 10 multiplied by pq. And we'll put a plus sign because this is positive. So if we were to expand these terms with 2 multiplied by 10 pq as 20 pq, which matches the middle term. So this is now in the form of a squared plus 2ab plus b squared. And we saw earlier that this can be factorized to be a plus b multiplied by a plus b, or pq plus 10 multiplied by pq plus 10. In the fourth example, we're asked to factorize the expression 81 minus 144x plus 64x squared. So we'll need to rewrite this expression. So 81 is now 9 squared, and 64x squared is now 8x, the entire thing squared. So with a squared with a being equals to 9, and b squared with b being equals to 8x. And the middle term is in the form of minus 2ab. So we'll copy minus 2 multiplied by a, which is 9, multiplied by b, which is 8x. So if we were to expand these terms out, minus 2 multiplied by 9 multiplied by 8 multiplied by x, that is basically minus 144x. And so this is now in the form of a squared minus 2ab plus b squared, with a being equals to 9 and b being equals to 8x. And we saw earlier that this can be factorized to be a minus b multiplied by a minus b. Or in other words, 9 minus 8x multiplied by 9 minus 8x. To summarize, consider the perfect squares. A plus b, the entire thing squared. That can be rewritten as a plus b multiplied by a plus b. And that is a multiplied by a plus ab plus ab plus b multiplied by b. And that simplifies to a squared plus 2ab plus b squared. Consider a different perfect square with a minus b, the entire thing squared. And that is equals to a minus b multiplied by a minus b. Expanding that, we have a multiplied by a minus ab plus b multiplied by b. And that is equals to a squared minus 2ab plus b squared. Therefore, the perfect square factorizations are as follows. With a squared plus 2ab plus b squared, which is this term here, as being equals to a plus b multiplied by a plus b, being this term. And that is equals to a plus b entire thing squared, which is this term. So all we've done here is to rewrite this line backwards. And so when you're given this expression a squared plus 2ab plus b squared, you could factorize this to be a plus b multiplied by a plus b, and that equals to a plus b squared. Similarly, with a squared minus 2ab plus b squared being this term, as being equals to a minus b multiplied by a minus b, being this term, and that is equals to a minus b the entire thing squared. So when you're given an expression of this form, you can factorize that to be a minus b multiplied by a minus b, or a minus b the entire thing squared. Thank you very much for watching. This is Master Mathematics Minutes.